in this video we will do a quick recapitulation of similar triangles. In the previous video we have discussed what are similar triangles and the proof of similar basic proportionality theorem was also discussed. Now, so just recapitulating that, similar triangles are the triangles which have the same shape but different size. Now coming to the basic proportionality theorem, the first concept that we will be using this in this chapter for solving the problems is basic proportionality theorem, also called as Thales theorem. In short, it is called as BPT. So what does it say? If a line is drawn parallel to one side of a triangle, then to intersect other two sides in distinct points, then the other two sides are divided in the same ratio. I read it again slowly, just observe the wordings and just try to understand that. If a line is drawn parallel to one side of a triangle, look at this triangle. This line DE is drawn parallel to AB to intersect other two sides in distinct points. Is this line not intersecting the other two sides, that is AC and BC, at two distinct points, that is D and E? So this DE is intersecting AC at D and BC at E. Then the other two sides are divided in the same ratio. What does it mean? So DE is drawn parallel to AB, DE is drawn parallel to AB, then the other two sides are in the same ratio, meaning is CD upon DA, CD upon DA will be equal to CE by EB, CE by EB. The essence of this statement is you can see in this, that if DE is drawn parallel to AB, then CD by DA will be equal to CE by EB. Okay. Now we also have the converse of this. So in the BPT what we had? We had that DE is drawn parallel to AB. Then we said that the sides are divided in the same proportion. When it comes to converse of BPT, what we have? We have the same ratio. We don't know that this line is drawn parallel to QR. We just know that PS divided by SQ will be equal to PT upon TR. The ratio of these two sides is equal. The first thing which we know is this. Then we can say that ST is parallel to QR. Because they are proportional, we can say that ST is parallel to QR. The next one is, the criteria for similarity of triangles is angle-angle similarity, side-angle-side similarity and side-side-side similarity. Coming to the first one, here it is written AA or AAA. What is the difference? Let us first talk about AAA. So if we have two triangles and we need to prove that these two are similar to each other, then we have to show that the corresponding angles of the first triangle is equal to all the corresponding angles of the second triangle. So if you see particularly, then angle A is equals to here angle P, and angle B is equals to angle R, and angle C is equals to angle Q. It means all the corresponding angles of these two triangles are equal to each other. So this is the first case wherein we have all the corresponding angles of the triangle equal to the angles of this second triangle. Then what is this AA? So if any two corresponding angles are equal, if we take two triangles and if only two of the angles are equal, okay, then the third angle will automatically be equal by angle sum property. This is applicable for triangles. So what does it say? Here we were showing that three angles were equal to the three angles of corresponding angles of PQR. But what we are saying here, even if we show that two of the angles of the first triangle are equal to the two angles of the corresponding angles of the second triangle. Here we have angle C is equals to angle E and angle B is equals to angle F. Then it is enough that to prove that these two triangles are similar to each other, because the third angle will automatically be equal. If you have 60 plus 40 is 100, by angle sum property we have the sum as 180. So, angle A is equals to 180 minus what is the sum of these two angles? 100. So, you will get 80. So, angle A measure is 80, and here coming to angle D, the sum of the angles in DEF is 180, and if you subtract this, the sum of these two remaining, that is 100, 180 minus 100 is 80. So, again you will get the angle D as 80. So, it is not necessary to show the third angle. So, just if we can show that two angles of the first triangle are equal to the corresponding two angles of the second triangle, then we can say that these two triangles are similar to each other. If you have three angles equal, no issues, but it is enough to show that two angles of the first triangle are equal to the two angles of the corresponding two angles of the second triangle. Then we can say that these two triangles are similar to each other. The second one is side angle side. In this similarity, as you can see, side angle side, it means this angle is formed by these two sides. Here these two angles should be equal. Here angle A is equals to angle E, and these angles are included by which sides? AB and AC, and this is EF and EG. So, if the ratio of this is equal, if these sides are proportional, then like you have AB upon EF is equals to AC upon EG, and these two angles are equal, angle A is equals to angle E, then these two triangles are said to be similar to each other. That is, if one angle of a triangle is equal to one angle of the other triangle and the including sides are proportional. These are the including sides, right? AB upon EF is equals to AC upon EG. Including sides are proportional, then we can say that these two triangles are similar to each other. The third one is side similarity. In this, if all the sides are proportional, we can say that these two triangles are similar to each other. That is nothing but PQ upon ST. If suppose ST is the corresponding side, PQ upon ST is equals to QR upon TU and PR upon SU, because QR corresponding side here we are considering it as TU, and PR corresponding side here we are considering as SU. So, if the ratio of the corresponding sides is equal, then we can say that by SSS similarity, these two triangles are similar to each other. Here, this is also an interesting theorem, that is the ratio of the areas of similar triangles, I repeat, the ratio of the areas of similar triangles is equal to the ratios of the squares of their corresponding sides. It means if two triangles are similar, if I take triangle ABC and triangle PQR, if they are similar to each other, then the area of triangle, ratio means area of triangle ABC by area of triangle PQR. Ratio of this, what is this? Ratio of the areas of these two triangles will be equal to ratio of squares of their sides. So, AB is the corresponding side, suppose of AB is PQ, then AB square by PQ square will be equal to BC square. If let me show it using a figure. Here ABCs, and let this be PQR. If I mark this as A, B, C and this as P, Q, R, then area of triangle ABC divided by area of triangle PQR will be equal to AB square by PQ square. That what is that? Ratio of the squares of the corresponding sides. Then the corresponding side of suppose BC is QR, then BC square is by QR square. that will be equal to, suppose the corresponding side of AC is PR, that will be equal to AC square by PR square. So, if we are aware of these statements and how it works, then we can apply in our problems. That is, if two triangles are similar, then the ratio of their areas will be equal to the ratio of the squares of their corresponding sides. Here AB square by PQ square is equals to BC square by QR square, and that is equals to AC square by PR square. Then coming to the next one, suppose if you have a right angle triangle. Before I explain this statement, let me just look at this figure. If I have a right angle triangle ABC, and what is this BD? BD is the perpendicular drawn from, actually our right angle is at vertex B, right? So, BD is the perpendicular drawn from the vertex having the right angle, that is BD is perpendicular to AC, and which vertex is chosen? The vertex having the right angle. Then this triangle ABC will be divided in such a manner that if you observe this triangle will be similar to this triangle. What is the name of this triangle? ABD is similar to triangle, suppose ADB. If I what I have written, I will use the same letters. So, triangle ADB will be similar to triangle BDC. ADB is similar to BDC. As you can see here, ADB is similar to BDC, that is nothing but the smaller triangle up here, that is ADB is similar to BDC, the down one. Okay, these two triangles will be similar to each other, and also each one of them will be similar to the complete triangle, that is ADB will be similar to ABC, complete triangle, and the smaller one, second one, that is BDC will be similar to this complete triangle ABC. Now, let us read this statement, you will understand it more clearly. Now, in it, if a perpendicular is drawn from a vertex of right angle, a perpendicular is drawn from the vertex of a right angle to the hypotenuse in a right angled triangle, then the triangles formed on both sides, the triangle formed on both sides of the perpendicular are similar to the whole triangle. They are similar to the whole triangle and also to each other. This is the statement. That is, if you write it like this, if BD is perpendicular, ABC is a right angle triangle, okay. If BD is perpendicular to AC, then ADB will be similar to BDC, they are similar to each other, and ADB will be similar to ABC, the entire triangle, right, and BDC will be similar to the complete triangle, that is ABC. Okay, this is one of the important statements. Coming to the next one and the last one, that is Pythagoras theorem. We have come across in trigonometry also. Then let us repeat this once again. In a right angle triangle, what does the Pythagoras theorem say? In a right angle triangle, the square of the hypotenuse is equal to the sum of the squares of other two sides. Let me explain. If I take a right angle triangle, as you can see here, if I take a right angle triangle like this, what is the hypotenuse? AC, the side opposite to 90 degrees is called as the hypotenuse, right? The square of the hypotenuse will be equal to the sum of the squares of other two sides, right? So, if we have in triangle ABC, which is a right angle triangle, AC square will be equal to AB square plus BC square, sum of the other two sides, squares of other two sides. The converse of Pythagoras theorem states that in a triangle, see here it was already we knew that it is a right angle triangle, but here we do not know that it is a right angle triangle. We are saying just in a triangle, if the square of one side is equal to the sum of the squares of other two sides, then the angle opposite to the first side, here the first side is AC, right? The angle opposite to the first side is a right angled triangle. So, we are proving that it is a right angled triangle when you have AC square is equals to AB square plus BC square. In converse, we did not knew that it is a right angle triangle. What we knew was the square of AC, that is AC square is equals to AB square plus BC square. That is why we could say that it is a right angle triangle. And where is that right angle triangle? Opposite to the first side, that is opposite to AC is angle B, and this angle B is 90 degrees. If you are aware of the concepts, you can easily apply those to the problems. Map the summary of similar triangles in your mind using this mind map. You can also take the screenshot of this. Thank you.